Hi! Welcome to another video prepared for you by Magandang Math. I am Teacher Cecil and I will be discussing the geometric sequence. What do we mean by geometric sequence? Do you have any idea what is it all about? Right, a geometric sequence is a sequence. It definitely shows a pattern. But what makes it different from any other sequences? That is, a geometric sequence, also known as a geometric progression, is a sequence of non-zero numbers that has a non-zero constant common ratio which is not equal to 1 between any two consecutive terms. Each term is found by multiplying the preceding term by the common ratio. Simply, if we heard geometric sequence, it is associated with the word common ratio. Why? Because it is one of the essential characteristics that a geometric sequence possesses. It is what makes it different from any other sequence. This is also used to find each term in a geometric sequence. Again, a geometric sequence is associated with the word common ratio. Now, by definition, let's check if you can identify if this sequence is geometric or not. The sequence is 3, 15, 75, 375, 1875, and so on. What can you observe in the sequence? That's right. There is a pattern, and the pattern shows that each term is found by multiplying 5 constantly by the preceding term. In this case, 3 times 5 is 15. 15 times 5 is 75. 75 times 5 is equal to 375, and 375 times 5 is equal to 1875. Definitely, this sequence is an example of a geometric sequence. The constant 5 is what we call the common ratio. But since you have heard and seen how each term is found in this sequence, what do you think is the next term after 1875? That's right. That is 9375. It can be derived by again multiplying the common ratio, which is 5, by the preceding term 1875. So, that is a way of identifying if a given sequence is a geometric or not. Now, we will be proceeding in finding the next term of the geometric sequence. And to do that, we can be guided by this following formula. First, formula in finding the next term of a geometric sequence. That is, a sub n is equal to a sub n minus 1 times r, where n refers to the placement of the term. Is it the first term, second term, third term, fourth term, and so on? And the ratio of the successive terms, usually denoted as r, is called the common ratio. Aside from that, we also have a formula in finding the nth term of a geometric sequence, and that is a sub n is equal to a sub 1 times r raised to n minus 1. Again, n is the placement of the term, r is the common ratio, and a sub 1 will be the first term. Now, let's apply this in our given example. The heights of a bungee jumper's bounces presented below. However, the height in the fourth bounce is not shown. From the pattern it shows, what will it be? Let us first observe the sequences of the height in the table. Now, let's consider the first bounce height as the first term, following the second as the second term, the third bounce height as third term, and so on. With that, a sub 1 is equal to 250, a sub 2 is equal to 150, and a sub 3 is equal to 90. Now, we're going to proceed in the basic steps in finding the next term of a geometric sequence. Let's start. For the first step, identify the common ratio by dividing the succeeding terms. To find the common ratio, succeeding term divided by preceding term. Therefore, we can use a sub 2 over a sub 1 or a sub 3 over a sub 2, wherein a sub 2 over a sub 1 is equal to a sub 3 over a sub 2. Since we don't know if the sequence is geometric, let's check first if the ratio is common. So as illustrated, a sub 2 over a sub 1, which is 150 over 250, is equal to 0.60. To check if it is similar to the other consecutive terms, we have a sub 3 over a sub 2, and that is 90 over 150, which is also equivalent to 0.60. Therefore, our common ratio is equal to 0.60. The sequence of the height of the bungee jumpers is a geometric sequence. Now, we can definitely find the height of the fourth bounce of the bungee jumpers, and that is the step 2. Multiply the common ratio or the R to the preceding term to find the next term, or we can use the formula in finding the next term of a geometric sequence, that is a sub n is equal to a sub n minus 1 times R. So let's first try to use the formula. We have a sub 4 is equal to a sub 3 times R. A sub 3 is equal to 90 and our R is equal to 0.60. 90 times 0.60, we have 54. A sub 4 is equal to 54. To check, let's go back to our illustration. As you can see, the first term, that is 250, is multiplied to 0.60, we get 150. 150 times 0.60, we get 90. And 90 times 0.60, we get 54 as the height for the fourth bounce. Therefore, it is proven and checked that the height of the bungee jumper's fourth bounce is 54 feet. That is how we apply the formula, and we simply multiply the common ratio to the preceding term to find the next term. Easy, right? Let's try it again. In the next example, we're going to find the next two terms of the geometric sequence 100, negative 50, 25, and so on. Herein, let a sub 1 is equal to 100, a sub 2 is equal to negative 50, and a sub 3 is equal to 25. Again, first step, identify the common ratio by dividing the succeeding term. So to find the common ratio, it is succeeding term over preceding term. We can use a sub 2 over a sub 1 or a sub 3 over a sub 2. As we are told that we are looking for the next terms of the geometric sequence 100, negative 50, 25, and so on, we don't need to check that the ratio is consistent between every two consecutive terms. Instead, we can choose any two consecutive terms. In this case, the common ratio can be found from the third term and second term, and that is 25 divided by negative 50. Therefore, our common ratio is equal to negative 0.50. Now, we can proceed to the second step, and that is multiply the common ratio to the preceding term to find the next terms, which are a sub 4 and a sub 5, or we can simply use again the formula in finding the next term of a geometric sequence, and that is a sub n is equal to a sub n minus 1 times R. Let's first find our fourth term, or a sub 4. So we have a sub 4 is equal to a sub 3 times R. From the given, our a sub 3 is 25 and our computed common ratio is negative 0.50. Therefore, a sub 4 is equal to 25 times negative 0.50, which is equal to negative 12.5. Now, for a sub 5, we have a sub 4 times R. Since we have previously computed that a sub 4 is equal to negative 12.5, therefore, a sub 5 is equal to negative 12.5 times negative 0.50, which is equivalent to 6.25. Therefore, the next two terms of the geometric sequence are negative 12.5 and 6.25. Is it clear? I hope it is. But before proceeding to another example of geometric sequence, let's take a look to our previous examples. What can you observe in this geometric sequence, specifically from the sign of each term? It is alternating, right? With that, remember that when the term in a geometric sequence alternate between positive and negative, the common ratio is negative. Previously, we have identified that the common ratio for this given geometric sequence is negative 0.50. With that, we can assume that the next terms in this sequence will be alternating to positive, and so on. At this point, let's level up your understanding. Let's level up the concept by finding the nth term of the geometric sequence. Specifically, let's find the 8th term of the geometric sequence negative 5, negative 5 over 4, negative 5 over 16, and so on. Again, for step 1, identify the common ratio. To find the common ratio, succeeding term over preceding term. Thus, we can use a sub 2 over a sub 1 or a sub 3 over a sub 2. We can also have a sub 4 or a sub 3 depending on our given. In this case, let's now use a sub 2 over a sub 1. A sub 2 is equal to negative 5 over 4 and a sub 1 is equal to negative 5. The quotient for these two terms is equal to 1 over 4. Therefore, the ratio is equal to 1/4. Now, for the second step, since only 3 terms are given in the geometric sequence, we can use the formula for the nth term of a geometric sequence to find the 8th term. And that is a sub n is equal to a sub 1 times r raised to n minus 1. From the given, a sub 1 is equal to negative 5 and our computed common ratio is equal to 1 over 4. Now, let's substitute these values. We have a sub 8 is equal to negative 5 times 1/4 raised to 8 minus 1. Simplifying, we get negative 5 times 1/4 raised to 7. Simplifying the exponent, we have negative 5 times 1 over 16,384. And that is negative 5 all over 16,384. Therefore, the 8th term of the sequence is negative 5 all over 16,384. Basic, right? This is a mere introduction of the geometric sequence. In this video, I have taught you how to find the common ratio, the next term, and the nth term of a geometric sequence. Thank you for making it until the end of this video. I am Teacher Cecil, and this is Magandang Math telling you that mathematics is everywhere, and definitely, mathematics is beautiful. Bye!